Is your maple syrup production a steaming success, or are your energy bills thinning out your maple syrup profits? In this video, we will show different methods that can save you time and reduce the energy needed to transform watery tree sap into a family favorite. Producing maple syrup is a tradition in many areas of the northern United States and Canada. A few maple trees and a stock pot, and you can make some pure sweet gold for your pancakes. Commercially, it can be a very profitable enterprise. Energy is a key ingredient for producing maple syrup, and it's the largest production cost component. If you use too much because of an inefficient system, some of your profits are leaving along with all that water vapor. Until the evaporator was invented in 1858, maple syrup was produced in kettles over open fires. Early evaporators used flat-bottom pans which take about 4 gallons of heating oil, or the equivalent energy content, to produce 1 gallon of maple syrup. With modern evaporator flue pans, heat recovery equipment, and reverse osmosis technology, the amount of energy can be reduced to less than 1 gallon of heating oil, or the equivalent, to produce a gallon of maple syrup. Maple syrup production begins in the spring when days are sunny, with temperatures in the 40s and freezing nights in the 20s. Sap rises in the trees during those first warm days of spring as the tree moves sugar reserves from the roots to the branches. If a hole is drilled in the trunk of the tree, sap will run out and can be collected on warm days. A bucket is the traditional method of collecting sap, but sap has to be collected from the trees daily. Today, larger maple syrup operations use plastic tubing to collect the sap from the trees and pipe it to a central collection tank. The sugar content of hard maple tree sap is about 2.1%, but varies from 1 to 5%. To become maple syrup, the sap has to be concentrated to 67% sugar content. Approximately 40 gallons of water has to be removed to concentrate the sap into 1 gallon of maple syrup. It takes about 1,000 BTU to evaporate a pound of water. So boiling off 40 gallons of sap requires 325,000 BTU if the evaporator system was 100% efficient, which they never are. Boiling is an energy-intensive process, so making changes to increase energy efficiency can have big payoffs. Technology such as reverse osmosis is used in conjunction with evaporator pans with large surface areas to reduce the energy input. Reverse osmosis, or RO, is a filtration system that passes the sap over a partially permeable membrane that allows pure water to pass through, but blocks minerals, sugars, and other molecules, thereby concentrating the sap and removing pure water. Producers typically concentrate sap to 12 to 15% sugar before boiling. This removes over 80% of the water, which reduces boiling time and energy input. Reverse osmosis units can range from a capacity of 50 gallons per hour to more than 7,600 gallons per hour. Of course, some boiling is needed to caramelize the sugars and impart the maple flavor. The pan used for boiling sap has changed over the years from flat-bottom pans to drop or raised flue pans. A large heat transfer surface area is key to the efficient transfer of energy from the fuel to steam. This drop flue pan has 10 narrow extensions that extend 5 inches down into the firebox to maximize heat transfer. This increases the surface area by 400%. Another way to save energy is to use the steam from the boiling process to preheat the sap before it enters the evaporator pan. To do this, sap is piped through a heat exchanger mounted in a hood over the evaporator pan. As the sap passes through the heat exchanger, energy is extracted from the steam vapor, increasing the sap temperature before it enters the evaporator pan. Preheaters can reduce energy use by 15 to 20%. Another way of reducing energy use is to utilize the steam coming off the main pan to heat a steam pan. This is a second pan that sits directly above the evaporator pan. Air is injected into the sap to promote evaporation. A steam pan can reduce energy use by 50 to 65%. In summary, the energy required to make maple syrup can be decreased by about 75% by using the following: reverse osmosis technology to reduce the amount of sap to boil, a flue evaporator pan to increase the heat transfer surface area, a steam pan to extract heat from the steam, or a preheater to heat the sap before it enters the evaporator system. With these changes, your sugar operation can become a sweet, sticky amber success.